Well, hello there. So let's look at some of these example programs that come bundled with the Arduino IDE system. I'd like to cover what some of these examples do and some basic skills you should have, like printing things out, and then some common errors that I've seen students make when modifying these examples, especially for our Mechatronics class. If you're running the Arduino IDE, under File, Examples, you should find all of these examples. So the ones we're covering today are all under the Basics set, but there are a lot more examples, and depending on which board you have selected, you'll find examples for those particular boards and things. So definitely use these. They're a great fallback if you're not sure if your Arduino is broken. See if it will run the Blink program. And if you just want to see examples of how things are done, that's what this is for. So you don't have to copy and paste anything, just open it up from the examples menu. They're all well documented on the web, so if you find the examples link on our course page, or you just Google for it, each example has a whole tutorial, and they go generally line by line explaining how it works. So if I don't give you enough information in this video, please read through the documentation on anything you're confused about, and follow up with me. I'm happy to help. All right, so one example of a skeleton code. This is called the bare minimum example, and it's like it says, the bare minimum Arduino program requires two functions, the loop function and the setup function. Remember, setup runs when the chip is rebooted or turned on, it runs setup, and then when setup finishes, it jumps to loop and runs all of the code from top to bottom of loop, and when loop finishes, it jumps back to the top and runs loop again, over and over, forever. So you always need these two functions for an Arduino program. We've seen the Blink program before. It's a great example of how to blink an LED pin. It's not efficient at all because it has all these delays where it just sits there and does nothing, but it's definitely a go-to if you want to test your Arduino. If you buy an Arduino, they normally come with a blinking light because they're tested with the Blink program before they're shipped. So in terms of reading inputs, digital inputs, which are on or off, there are two good examples, and they're slightly different from each other. There's DigitalReadSerial that reads a pin and prints it out to the serial port. And there is Button, which turns a LED on and off based on whether you've pressed a button or not. So one prints things out, one turns on and off an LED. So they're just both good examples. There are some things unrelated to the digital parts that are really interesting to me here. The global versus local variable decisions that whoever wrote these programs made. You can see here push button is a variable, an integer variable initialized to 2. This is a global variable because it's outside, its declaration is outside of any of the functions. We have a button state variable, another integer. This is a local variable, only accessible inside of loop because it's declared inside of loop. Here in the button example, we have an integer button state that's a global variable. And so it's not declared at the same time. This is a really common way to declare local variables in Arduino examples is to use a compound statement. So we have int button state equals digital read push button. This does two things at once. It declares the variable button state as an integer, and it finds it using this function call. So it's declaring the memory space, allocating the memory in the chip, which only happens once, and then it fills that memory in two things. And this is a source of many errors, as we'll see. This one declares it up here at the top as a global variable and then uses it down here. So it's separate declaration and definition. These two examples also do something very similar. This is AnalogReadSerial versus ReadAnalogVoltage. They both read a voltage on an analog pin using the analog to digital converter of the Arduino. And one prints it out, this AnalogReadSerial prints it out in the raw analog to digital conversion form. So if you took instrumentation, we learned about how to convert voltages to ADC readings, and that's what this does. So the Arduino analog to digital converter on the Uno and Nano, it's a 10-bit analog to digital converter with a range of 0 to 5 volts. So this will output a number between 0 to 1023, and that's what's going to print out. This ReadAnalogVoltage is a little more friendly for engineers. It reads the same thing, it reads the analog pin, but then it converts it to voltage using the value that it read times 5 volts divided by 1023 because it's a 10-bit analog to digital converter. Again, we're seeing the compound statement where we're declaring a local variable and defining the local variable, declaring a local variable, and defining a local variable. And these are trouble if you decide you want these to be global variables. So we'll see that later, but you can see these come up in a lot of the examples. We use ReadAnalogVoltage for a lot of the homework assignments in the beginning, so make sure you understand how it works. It's basically just initializing the serial port, and then it reads the voltage and converts the voltage. Because it's an analog to digital converter, it's whole numbers, so we use an integer here, but the voltage is a floating point because it has fractions or decimal points. The millis function is a useful built-in Arduino function that's a clock. Millis runs from when the chip reboots or powers up, millis starts at 0, and then it will give you a count of how many milliseconds, thousandths of a second, have elapsed since it rebooted. It's an unsigned long variable, it's a whole number, because it's how many milliseconds. Unsigned long is a 32-bit number. So this overflows in a few days, I can't remember exactly, but whatever 2 to the 32 minus 1 milliseconds is. That's how high you can count. So for normal things it's fine, but you couldn't use this for something like a calendar without having an extra counter to count how many times it's run over. This example here, blink without delay, is a really nice one. It's the blink program, but it doesn't hang the computer for a second in order to blink the light. So it turns the light on and off, but lets other things run. So if you're trying to avoid obstacles with your robot, you don't want it to keep driving forward for a second without looking for obstacles. So this lets you blink and do other processes in the background or in the foreground. So what it does is it looks at the current time, which it gets from the millis function, and it subtracts it from the last time it ran that. And if that number is greater than the interval, then it's time to change the state of the light. And so if the light is off, it turns it on. Otherwise, it was on, so it turns it off. And then finally, it actually turns the pin to match this state variable. So this just checks the clock, and if it's time to change the LED, it does. If it's not time, then this whole thing gets skipped and it runs the rest of your code. So it lets you do things like blink LEDs, but you don't have to pause the whole program in order to be off for a second or on for a second. So it's a nice way to see how to do things periodically in an Arduino program. Something like this is useful if you're seeing way too many prints. You can use a code structure like this to print out every second rather than continuously printing. Sometimes printing can really slow your program down, so you could use something like this to adjust how often something happens in your code. Serial print, we've already been seeing it in examples, but it is a really useful tool. It's really the only kind of debugger that Arduino has. It doesn't have a very good debugger, so we use serial print for everything. And there are two serial print commands. There's serial.print versus serial.println, print line. And the difference is they both print whatever is in parentheses here, but print line also hits a carriage return to bring the cursor back to a new line. Serial print prints the characters, but then the next time you print, it's going to pick up right where it left off on the same line. And because these serial print and serial print lines have to either have text in quotes all by themselves, or you can give it a variable and it will format the variable and print it out, but you can't mix them together like you can in most languages. We use several print statements in order to make a single line of print. So serial.print, the answers are colon space, prints out this part, the answers are colon space, and then the next print, because this is serial print and not print line, the next thing is going to come right here on the same line. So answer is a variable which must have 14 in it because the Arduino then prints out 14. And then the next thing is going to come right after the 4. So then we have a serial print space and space inside of quotes. So it prints the space and the space. And then it's going to print the variable II, which must be 3. And because this last one is print line, it's going to also print a carriage return, which will bring our print cursor back to the beginning to start over. So if you want to print a complete line with mixed text and variables, you do it as a series of prints, and the last one is print line. And you'll get to practice this in the homework. There are other special characters that follow along with the C standards, and they're called escape codes because this slash is normally the escape character. The most handy ones are \n puts a new line. So if you put a \n anywhere in a quoted string like this, it'll start a new line. So you can print more than one line with a single serial print command. On some terminal programs, you need R and N. N is the new line. R is the return, so some things N goes down and R sends it back. If you imagine old-fashioned typewriters, you could turn the typewriter and send it back to the beginning. So R and N were required on some things. And it's sometimes a Mac versus a Unix versus a PC thing, whether you need one or the other. \T is tab, so if you want to print a lot of numbers with even spacing between them, you can use tabs \T inside of these quoted strings and you'll get a tab character. And there are other ones if you want to do fancy things. Look at the serial print documentation for things like how to format the number of decimal points and other useful ways to print debugging information.